we actually submitted to Science this paper, and it has not yet been rejected, although probably it will be. But we submitted 2 or 3 months ago, so we are starting to have some hope that they will accept it. But we have learned that our controversial papers are not easily accepted, especially by science. So about 10 years ago, I had this idea that we could consider the Charney feedback, that if you have less vegetation, then you have higher albedo, then less rain and less vegetation in the Sahel. And then Sud at NASA also found another feedback associated with vegetation. If you have less vegetation, then less friction, surface friction, less convergence, and less rain. So that is a positive feedback that increases that. So we thought perhaps we can put large zonal panels and wind farms in the Sahara, mostly in the Sahara. I will show you a little bit. And we use the speedy model and dynamic vegetation, and putting the large solar panels decrease the albedo and the increased friction from the wind farms, and they both produced more rain. So this is the result. The vegetation grew back with a positive feedback and doubled the precipitation. So this is a beneficial geoengineering experiment that's more than enough to satisfy the energy needs. And these ideas started with Charney in the Sahel, which is the southern part of the Sahara, where the Sahara ends and becomes tropical forest. Is the intermediate region. This was the anomaly of the precipitation, and then in the 1970s, and for like 20 years or 30 years, it was a very strong drought. And Charney suggested that perhaps what was happening was that increasing the albedo through overgrazing would result in, well, let me discuss it further later. So he suggested that overgrazing increases the albedo, and that reduces the heat, and then the atmosphere produces downward motion in order to compensate, and that reduces precipitation, and it's a vegetation positive feedback that gets worse and worse. Many people have studied also the impact of sea surface temperatures, and they suggested that sea surface temperature could produce this, and that may also be true, and this is not doesn't deny what we did. So the Charney said less vegetation produces less rain, subsidence, less heating, increased albedo, overgrazing, and that this makes everything go worse. And Sud said less friction, less vegetation produces less friction and less rain and less convergence, and again a positive feedback. So both produce a reduction of vegetation, and that makes things worse. So if we have a large wind farm and a solar farm, we have to consider what will happen. And what I thought might happen is that the opposite of the same Charney and Sud mechanisms, but in the opposite direction. So if, for example, you have a solar farm and it's not, and you use not too not too modern albedo. the effective albedo gets reduced if you are not using panels that are just the most efficient of all, but more like 15% efficiency, which is what has been used until now. So the albedo decreases, and therefore there is more heat, and there is upward motion, and that increases precipitation. The precipitation increases vegetation, and so on. And if you put a wind farm, you increase the surface friction, and that increases the low-level convergence, increases precipitation, and again, it's a positive feedback. So we tested that, and the results were awesome. What I'm showing is the picture of, it's a figure that shows the impact of farms when we put farms where all these little dots are, and wind farms and solar farms were less strong, but produced warming, and the two together produced more warming. And the precipitation for the wind farm was, again, these are the location of the wind farm locations, and you can see that the impact is to increase the precipitation very strongly, especially in the Sahel, as Charney had predicted, that the Sahel would be being a transition area, would be the most changed. And the same thing with the solar farm, and the two together more than double the original control precipitation. And the feedback is, for example, by roughness and by vegetation. It turns out that the vegetation has much more impact. The feedback of the vegetation has more impact than the initial roughness change. So this is very, very encouraging, and actually the Sahel drought has an amplitude of about 0.3 to 1 millimeters per day decrease in precipitation on the average here. And the increase in precipitation in the model, so this was also for the model. And the increase, no, sorry, this is reality, but the model is quite realistic, and the control precipitation is relatively similar. It's quite similar to observe. And the change in precipitation from wind and solar farms after it spins up the vegetation, we took 100 years just in case to make sure that it spin up. So it's 1.33, so it's significantly larger than this. And our results suggest that the vegetation feedback is very powerful and could reverse the drought, the Sahel drought. And it also made me think that perhaps the green Sahara, which has appeared, I think it was about 5,000 years ago, the Sahara was wet or green, and perhaps this vegetation feedback is very important for that. So I guess, thank you very much for your patience.